Okay, so let's rewrite this as a single logarithm and simplify. Notice here how we have a same base. This is all base 7. Okay, so notice how we also have, this is a fraction. This is 5 over 2, which is the coefficient of log 7x. And we have a plus sign and a minus sign. What can we do? So right off the bat, I'm just going to work left to right. Going to focus on the plus sign here. And we know the log rules. When we add, you can almost go backwards, combine it, and treat it like a multiplication. So this here is log base 7. We have x squared. This is going to be times x. So if you go backwards, you have a multiplication here. You can break it down to a plus sign here. So we're literally going backwards. And we have minus, and I'm going to write this very clearly. 5 over 2, log 7x. So this here, if you really want, you can just use exponent law. X squared times x is x cubed. So I'm going to just clean that up a bit, x cubed. And what we have is we have log something minus, and before I do anything, okay, so before I do anything, I'm just going to take this coefficient here, I'm going to throw it back up. Remember, exponent law says you can drop the exponent down and in front, back and forth. So let's see what happens here. Okay, so I move the 5 over 2 back to the exponent here. And so there is our exponent, and we have a minus sign here. So now I'm going to treat this like combining these logs to be a division statement. So we have log base 7, we have x cubed divided by something, and that something happens to be x to the 5 over 2. Notice how when you have a division, it becomes a minus over here. So to finish this off, we're just going to simplify using exponent law. When we have the same base, we have exponents being subtracted. 3 minus 5 over 2. I'm just going to use some scratch work on the side here. This is 3 minus 5 over 2, which is the same thing as. So the number 3 became 6 over 2. And when you subtract, 6 minus 5 is 1. We have the 1/2 here. So there we go. We have log base 7 x to the 1/2, which you're welcome to drop in front as well. So this becomes, so we're going to drop down the exponent here. We have 1/2 log 7x, and that's our final answer. We simplified and wrote as a single logarithm right there. 1. Okay, on page 398, example 4, we're dealing with sound intensity. We have this beta, just some Greek variable, just like y or whatever variable you may use, equals 10 log intensity over some intensity standard, some very soft intensity standard of this is how loud something is. We're dealing with beta as being in decibels, and this is a formula which you'll probably get. We're given that the chainsaw is 85 decibels, and we have an epic battle here versus the max setting on your earphones. If you want to go deaf fast, clearly the bigger number wins. So just listen to music at max. Then you don't have to listen to your annoying teacher. So what we have here is 110 versus 85. The question is how many times more intense it is. So we're going to use the formula. The decibels get plugged into here. And so we have 85 equals blah. And we're talking 85 is about the chainsaw. It starts with letter C. So we have the intensity of the chainsaw up here. And we have the earphones, which starts with letter E, having letter E over here. So this question simply becomes a matter of converting log to exponential form. In fact, before I do anything, I'm just going to divide both sides to get rid of the 10 here. So what we have is something equals something. In math, you're allowed to divide both sides by 10. What do we have here? We have 8.5 is equals to log IC over some intensity 0 there. So we literally just divided both sides by 10, and the 10 disappeared on the right-hand side. So logarithms have an assumed base of 10, and remember for logs, it's going to be the base to the exponent, other side of the equal sign, is equals to the answer, which is glaringly here, right beside the logarithm statement here. So let's convert it. 10 to the 8.5 is equals to intensity C over intensity initial, and you multiply both sides to get rid of this I0. So I'll just put the I0 here, and there's our answer. The intensity of C, the chainsaw, is this strong. 10 to the 6 is a million, 10 to the 7 is 10 million, 10 to the 8 is 100 million, 10 to the 9 is a billion, so it's probably somewhere in between. It's a huge number. Let's just work this one out down here. We have divide by 10 both sides. We have 11 equals log. So we have 10, the hidden 10 here, 10 to the 11. 10 to the 11 is equals to IE divided by IO. And this I naught here, I'm going to multiply both sides. It goes here on the left. And now we can compare. Would you rather have 10 to the 8.5 cookies, or would you rather have 10 to the 11 cookies? And hopefully you want more, unless you're on a diet. And so what we have is the bigger one divided by the smaller one. And we have the same base. Exponent law says we subtract. And so here, how many times bigger is it? The bigger one, which is clearly the earphones, divided by the smaller ones, is going to be 10 to the 11 minus 8.5. So the answer is 10 to the 2.5. So this is a perfectly acceptable answer. You can say that the earphones are 10 to the 2.5 times louder or more intense than the chainsaw. And you can leave that as your final answer without a calculator, or you could use your calculator and evaluate it, which should be about. So we'll say this is approximately 316.2, and this is if you have a calculator. And if you have no calculator, you can always say that 10 squared is roughly 100. You can say that 10 cubed is 1,000. So if you're given a multiple choice test, and the choices are, is it 80, is it 1,000, or some number in between, it's probably that in between number, because it must be between exponents 2 and 3. Let's try this pH problem on page 399, example 4, your turn. And you'll be given this formula, pH equals negative log hydrogen ion concentration. You can just treat this as a variable. So pH of 7 means neutral, neither acidic nor alkaline or basic. And so generally the acidity is from 0 to 7, means very acidic, closer to 0, and very alkaline as it's closer to 14. We're given that cola is acidic, pH is 2.5. We're given that milk, of all things, is still acidic at 6.6, but not much. And so when you plug these pHs into the formula, we get these equations here, and now the rest is math. Just divide both sides by -1. There's other ways to do it, but we'll just stick with this way for now. When you divide both sides by -1, we have negative 2.5 is equals to log hydrogen concentration. And we have negative 6.6 is equals to log hydrogen concentration. So based off that, we're just going to rewrite it as hidden base 10. 10 to the negative 2.5 is equals to hydrogen concentration. And over here, we have 10 to the negative 6.6 is equals to hydrogen concentration. So apparently, they're different. And the question is how many times more, and we simply have to take the bigger number divided by the smaller number. Now, the question is, which is bigger? So we're going to take the bigger number divided by the smaller number. This number here is bigger. If you think of the 10 to the negative 2, that's 10 to the 100. If you think of this as 10 to the negative 6, that's 1 over 6 zeros. So this is clearly smaller. So let's do it. I'm going to take 10 to the negative 2.5, bigger number, divided by 10 to the negative 6.6. And what we have is 10 to the negative 2.5. Exponent law says, same base, subtract. We're going to subtract a negative number, which means we add. And so we get 10 to the 4.1, which is an absolutely valid answer. This many times more acidic. So in conclusion, we have cola is this many times more acidic than milk versus milk. And if you work it out here, even without a calculator, we know that 10 to the 4 is approximately, this is 4 zeros, 10,000 times more acidic. And if you say, what's 10 to the 5, that's going to be 100,000. And now we know that this is only 4.1, so that's going to be a little bit on the lower end. And so just be careful. One interesting insight with this kind of problem is if you get the initial values of 2.5 and 6.6, you can simply subtract them, and we know that the difference is going to be 10 to that difference, 10 to the 4.1. And by knowing that this exponent here is 10 to the 4, it's going to be many times bigger. 10 to the 3 would be 1,000, 10 to the 4 would be over 10,000.